Okay, so today's lesson is on slope. The learning goals to extend from what we did yesterday is to calculate slopes algebraically. Okay, before we do that, just to make sure yesterday's lesson was clear, we covered the topic of slope, which is rise over run. You can calculate rise over run anywhere on a graph because the rate of change or the slope of the line is the same everywhere, so you could do it from here. You draw your rise and your run, which would be 5 divided by 5 equals 1. We could do a little triangle, rise of 1, run of 1, 1 divided by 1 is 1, or you could do a really large triangle. 10 divided by 10 is 1. So no matter where you do it, the slope is the same. So for the examples that were on the exit card that you had yesterday, it would be 3 over 5. Okay, and it's okay to leave slopes as fractions. So that would be it. Rise over run, 3 over 5. It is already in lowest terms. For the hummingbird question, it's a rate of change. So you want to know how many times per second. So if it's 1800 every 30 seconds, rise over run, or rate of change, times per second. Okay, we just do the division. 1800 divided by 30 is 60. So 60 times per second. So that's just the answers from yesterday. Okay, so we're going to go on. The topic today is to calculate the slope algebraically, and to do that you need to know the address or the coordinate of each of the points. So if I had to label point 1, remember this is the x-axis and this is y, and points are always labeled x then y. The point number 1 would be -2 for the x value and -1 for the y value, because it's 2 this way on your x to the left and 1 down, which is -1. For point 2, I'm on the x value 1, 2, 3, 4, so that's x is 4, and the y value is 3. So whether you have the picture, you've been given the points, now you know what x and y are for each of the points. The slope formula is y2, or the second y value, minus the first y value, divided by x2, so the second x value, minus x1, the first x value. So these are not exponents. Keep that in mind, that they're just telling you which point or which coordinate to consider. So if I look at the second y value, that's 3. So this just becomes a matter of subtracting carefully and taking into account all the negative values, the integers that come into play. So the second y value is 3, it's right here. The first y value is -1, so y2 minus y1, that value minus that value, divided by x2, the second x value, minus the first x value. So x2 is right here, x1 is right here. So we're going to be subtracting in this order, this one minus this one, and this one minus this one. And it's rise over run, so the change in y is vertical, so the rise has to come first. And then x is the change, the run, or the change in x. Okay, so 3 minus -1, that's 4. Okay, and 4 minus -2, that's 6. And reduce, as I said, you can leave it as a fraction, but reduce it to lowest terms. And you can do that if you forgot how, either on your calculator or by finding a value that divides evenly into both. So if I choose 2, I can reduce 4/6 to 2/3. Okay, a few more examples. So here we have the endpoints, we don't have the picture. It's just a matter of subtracting carefully. So the slope here, slope is equal to y2, the second y point, minus y1, divided by x2 minus x1. Okay, so this is our second y value. We'll start with that. 7 minus 5, okay, divided by, look at the x values, 2 minus 1. Okay, and you get an answer. 7 minus 5 is 2. 2 minus 1 is 1. And as small or as low as possible, 2 divided by 1 is the whole number 2. So the slope is 2. Okay, we'll do it again. Slope for the second example, except now we have some zeros and negatives, just to be careful. So y2 minus y1, x2 minus x1. The second y value is negative 2. The first y value is 0. The second x value is negative 9. The first x value is 3. Once we've written them in the proper spot, we just complete the subtraction. Negative 2 take away 0 is still negative 2. Negative 9 take away 3 is negative 12. A negative divided by a negative is a positive, and this can be reduced. So if I divide each by 2, and remember negative divided by negative, already that would be gone, the negative signs. So if I divide them by 2, divided by 2, divided by 2, I have the answer 1/6. Okay, so the slope of that line with the endpoints 3, 0, and negative 9, negative 2 is 1/6. Okay, one more time. Slope y2, the second y value minus the first one, the second x value minus the first one. So always remember y comes first, then x. And we're going to start right here with this value here, so 2 minus 10 over 5 minus 5. Okay, and we get into this situation, so negative 8 over 0. If you try to simplify that on a calculator, you'll recognize that this is called undefined because there's no value that can be divided by 0. So this slope is undefined. We'll talk more about that in class.